So welcome to this. This is the Further Maths Support Programme online revision session for Edexcel Statistics 2. And in this section we're going to be looking at the continuous uniform distribution. So this is quite a small session, but you need to be able to use the uniform distribution model, and you need to be able to derive the mean, variance and the CDF of it as well as answering general questions with it. So from June 2010, question 3, we have a rectangle that has a perimeter of 20 centimeters. The length x of one side of this rectangle is uniformly distributed between 1 and 7. So what we can state there is that x can be modelled as a uniform distribution on the interval 1 to 7. We're asked to find the probability that the length of the longer side of the rectangle is more than 6 centimeters long. Now this is actually quite a difficult question, but before we do this, I think it's worth just spending a little bit of time looking at the uniform distribution. So if we have a uniform distribution on the interval a to b, then the probability function of this is going to be 1 over b minus a. The reason I know this is pure and simply by drawing a picture. So if we think about a picture going from a to b, the uniform distribution is effectively a horizontal line, and the area's got to be 1. So this distance here is b minus a. So to create a distance, to create an area of 1, this has to be b minus a as well. So it's just worth bearing that in mind as we approach these questions. So in this question, it's a really good idea just to draw a picture. So we're talking about something that's got a perimeter of 20, and the length x of one side is uniformly distributed. So I'm going to call this length here x, which means that this length here is going to be 10 minus x. So we're asked to find the probability that the length of the longer side of the rectangle is more than 6 centimeters long. Now this can happen in two situations. Either x is the longest side, and if x is the longest side, then what we're looking for is the probability that x is greater than 6, or there is a second situation where 10 minus x is the longest side. So that's the probability that 10 minus x is greater than 6. And if we just do some rearrangement of that, we can see that that's the same as saying the probability of x being less than 4. So what I'm going to do is I'm going to draw this distribution. Now we've got what's going on. So it's uniform on the interval 1 to 7. So the height of this thing is 1/6 by using this statement here. And I want the probability of either being greater than 6 or less than 4. There's 4. Okay, so this has a length of 3. This has a length of 1, so the total area is going to be 3 over 6 from the first aspect plus 1 over 6 from the second aspect, and that's going to give me a probability of 2/3. Okay, so it's not mathematically difficult, it's just quite tricky to get your head around what's going on, and as I say, a picture of the situation is always a really good idea. So let's see how we're going to get marks awarded for this. You get 1 mark for basically just recognizing the fact that this is a uniform distribution and calculating this 1/6. Okay, you're going to get an independent mark and a method mark for calculating the probability that x is greater than 6, pure and simply because that is the logical thing that comes from the question. You then get another mark for working out the probability of x being 4 or below, which is quite nice. Your fourth mark is then gained by realizing that it's either greater than 6 or less than 4, so you get another mark for effectively adding them together, and this is dependent on actually getting this mark here, and then you get an accuracy mark for getting it completely correct. So as I say, this question technically isn't that difficult, but there's just lots of things you've got to be very aware of. So January 2011 question 3 goes on and says the continuous random variable x is uniformly distributed over the interval -1, 3. And we're asked to find the expectation and the variance. So just as a reminder, x can be modelled as a uniform distribution on the interval -1 to 3, which basically means that we have a probability density of if you want to write it properly, because that's sometimes useful, it's going to be 1 over 4. That's 3 minus 1, between minus 1 and 3, and 0 otherwise. So sometimes you are asked to write this. We're not for this question, but I think it's just worthwhile doing. Now, there are special formulae that govern the expectation and variance of continuous uniform distributions. And the expectation is A plus B over 2. It's the average. So that's going to be 3 plus minus 1 over 2, which gives me a value of 1. So you get your 1 mark for getting that correct. Secondly, for the variance of x, that's going to give me 1/12 of b minus a squared. And again, that's a standard formula that's given. So it's going to be 1/12 of 3 minus 1 squared. And that's going to give me a value of 4/3 once I've simplified it down. Okay, so you get 2 marks, 1 for using the formula b minus a squared over 12, and 1 for getting the correct answer, or any equivalent. Okay, of this, 16 over 12 will be perfectly fine as an answer. So we're then asked to work out the expectation of x squared. This comes from some concepts that we've looked on at S1, the fact that the variance of x is equal to the expectation of the squares minus the square of the expectations. And we've worked most of this out already, so the variance we've already worked out is 4/3. E of x squared is what I'm looking for. The expected value is 1. So a little bit of rearrangement with that is going to show me that the expectation of the squares is in fact 7 over 3. So you get 2 marks, 1 for dealing with this formula, and then 1 for getting the correct answer. We're then asked to work out the probability of x being less than 1.4. And to demonstrate this, again, I'd just like to draw a picture. So we're looking at the interval between -1 and 3. We've been figured out that we've got a height of 1/4, and we're looking for the probability of being below 1.4. So this distance here is 2.4, and we're asked to work out this area here. So the area, it's a rectangle, is going to be 1/4 times by 2.4, and that's going to give me 0.6. So it is useful to think about this as a rectangle. In fact, sometimes it's called the rectangular distribution, and drawing the distribution is quite a sensible way, I think, of working out the probabilities. It continues, so the continuous random variable x is uniformly distributed in the same way, and we're making 40 observations of x from that distribution, and we're asked to find the probability that at least 10 of these observations are negative. So really what we've got to do here is sort of understand the situation. So first of all, the probability that one of them is negative is going to be, again, just think about the picture, -1 to 3, and I'm wanting this probability here, which is going to be 1/4. So what we have is an interesting situation. So we really have a binomial situation now. We have 40 observations, and we are interested in how many of those are negative. So we're going to let y be the number of negative observations from this distribution, and we can see that that is following now a binomial distribution where we're doing it 40 times, and the probability of getting a negative observation is 1/4. Okay, and we want to find the probability that at least 10, so that's 10 or more of the observations are negative. Well, the inequality is pointing the wrong way, so we need to turn it around carefully. So we just need to think about the number that's going here. So we're going to have 0, 1, 8, 9, 10, 11, all the way up to 40, and I'm interested in 10 and above, which means I'm not interested in 9 and below. So that means we're going to have 9 here. Now this can be looked up in the table, and if you look at the binomial table 40 and we look at the probability of 1/4, we can find that y being less than or equal to 9 is equal to 0.4395. Once we've got that, we can calculate that through to give you 0.5605. So like a lot of questions like this, sometimes the distribution needs to be redefined because you're actually doing something subtly different with it, and this is the case in this situation. So let's look at where your 5 marks are allocated. So you get an independent mark for working out the probability of a negative observation. You then get 2 marks. You get a method mark and an accuracy mark for demonstrating that you understand that this question is all about a binomial distribution with parameters of 40 and 0.25. We then get 2 more marks, a method mark and an accuracy mark, for correctly finding the probability from the tables. So the uniform distribution generally is not too difficult, but pictures will help you see what's going on. Okay?